Assalamualaikum and very good morning. Today I will present you about my final year project. The title is 2D and 3D landscape mapping using terrestrial laser scanning. My name is Nurul Shafira binti Kamarudin and my supervisor name is Associate Prof. Dr. Zulkifli Maji, and thank you to my panel Dr. Zakri and Mr. Azman. Okay, let's proceed with my content. As you can see, there are 10 content that I will explain to you. First, introduction, problem, research question, aim and objective, methodology, data processing, result and analysis, recommendation, limitation, and last is conclusion. Okay, let's proceed with my introduction. In introduction, I will explain about maps, landscape, and the technology that I will use. A map is a visual representation of an entire area or a part of an area, typically represented on a flat surface. Usually, map will present using model such as 2D and 3D model. A landscape is a visual features of an area of land. It is landform and how they integrate with nature and man-made features. In this research, I will focus on two types of landscape. The first is sourcescape and the second is hardscape. For sourcescape, I will focus on tree, plant, and grass. And for hardscape, I will focus on footpath, road, and pole. I was use LiDAR and GIS as a tool for visualize landscape. In my research, I found 4 issues that I have to solve it. The first author is the Monk and Funkless, year 2000. The problem is one problem of participative planning process is communicating the relevant planning information among all the stakeholders in a understandable way. Second author is Barbertree and Galtertree, years 2003. The problem that they state is traditional planning such as map, diagram, tables, or text often fail to communicating the result to lay people. The third author is Whiston and Schwab, years 2008. The problem is in a participative planning process, 3D visualization have a high potential as an aid in understanding and communicating characteristics of landscape conditions by integrating visual and non-visual landscape information. The last issue is authored by Lovett and Epperton, years 215. The problem that they state is landscape visualization should be tailored in planning process stage to improve communicating effectively. For research question, how to create landscape mapping in 2D and 3D models using terrestrial laser scanning. Then for aim and objective, the aim of this study is to create landscape mapping using terrestrial laser scanning measure technique to create map in 2D and 3D model. And then for objective, the first is to identify problem in landscape planning. The second is to generate an 2D and 3D of landscape mapping. And the last is to develop the GIS database. Let's proceed with my methodology in my research. As you can see, there are 6 steps based on flowchart. And then 6 steps was split followed by the objective. Okay, I will proceed with data processing in methodology. I have to explain about data processing because in data processing it is very difficult part to finish it. First one is I use software Topcon Scan Master. The Topcon Scan Master that I use is to generate point cloud of landscape. As you can see, the right diagram is the whole data that I have gathered for the field, and then the right diagram is a data that I have already cropped, and then I choose to using in my study. For example, I using tree, pole, footpath, and then road. The second software is LiDAR 360. Okay, I use the LiDAR 360 for classification of landscape element. For example, I used to classify the importance of sourcescape and hardscape that I have to mention already. You can see at the diagram show the result of classification of landscape element. It show by colors. As you can see, the 3 colors for green, and then road for dark green. Pole color is pink. Footpath is purple, and then for land tower is grey. Spotlight, yes, spotlight. Okay, for software ArcMap, ArcScene and SketchUp, as you can see, there are 2 diagrams that I have to show it. The first diagram is ArcMap. I use the ArcMap to digitizing all the data. For example, tree, footpath, pole, and road. And then after I finish the digitizing, I proceed with do database. And then after the all database is already finished, I use the ArcScene to represent all the data in 3D. And then before I use the ArcScene, I have to import the 3D object such as tree, the type of tree, and then for type of pole. And then I will present all the object from I get for SketchUp and represent in ArcScene. After done with data processing, I will show you about my result. The first result about 2D map. As you can see, there are 3 features in the map. The first one is tree. The tree show with different symbol followed by type of tree. And then for the road network, there are two types of road network. For example, footpath and road. And then for pole, there are two types of pole. The first is lamp pole, and then the second is pole tower. As you can see at the right section of map, I put all of a picture about the tree that I get from the field, and then I put all in the map to make sure user can understand about the shade of tree. The second result is 3D map. I use ArcScene software for display this map. As you can see, all the element or features that I have mentioned in 2D map or display in 3D map. And then you can see clearly there are a lot of type of tree with different shape, and then you can also see type of pole. The first one is pole tower, and then is pole. In analysis, I use both of map 2D and 3D map to do the analysis. The first analysis is about comparison element of landscape using landscape plan from PHB with the new map of landscape. The first analysis I'm gonna use 2D map, and then for the second analysis I use 3D map to do a query. For the first analysis, I use landscape plan from PHB. As you can see, this is landscape plan that I get from PHB. At the plan, they display all about type of tree, and then road, and then also footpath. And then the second data that I have want to use is to the landscape that I have produced by using TLS. And then as you can see, there are right circle at the map. The right circle is mean the analysis area. And then for the first analysis, I'm gonna use qualitative analysis. Okay, this is first result of analysis based on table. You can see the first table is landscape plan from PHB. There are 6 type of tree, and then the total of tree is 218. And then the second table is new landscape mapping using TLS. There are 7 type of tree that are detection by using TLS, and then the total is 166. As you can see, only 3 type of tree are planted accordingly, followed by landscape plan. As you can see at the table, the first one is black spinner olive, second is gelang, and then pulai. then by using TLS, there are a new construction of pool tower in study area. They are detect using TLS. Okay, in the second analysis, I'm gonna use 3D map, and then we'll display at ArcSim. For the first query, is the total of black spinel olive tree. As you can see, the first diagram is show all the black spinel olive tree are selected, and then the second diagram it show all the attribute about the black spinel olive tree. At the second diagram, you can see the attribute about the tree. For example, is FID, shape, ID, and then for scientific name, common name, shape of tree, and then height of tree. And then as you can see at the bottom, the total of 15.8 from 270. For the second query, the total of gallantry with a tree height over 5 meter. As you can see, the first diagram show all the gallantry are selected, and then for the second diagram is they show about the attribute. As you can see, there are 20 of gallantry are selected from 270. Okay, for the last query is about total of pool. As you can see at the first diagram, they will show all the pool are selected, and then for the second diagram is show all the attribute about the pool, and then as you can see there are 9 of pool are selected from 10. Okay, for recommendation, there are 2 recommendations that are listed. The first one is using another 3D software such as SketchUp, Revit, and another suitable software 3D for the modeling the object. And the second is using unmanned aerial vehicle, UAV, or drone for cover the top of object. And then for limitation, there are 2 limitation. The first one is terrestrial laser scanning cannot cover the top of object, and then the second is need to using the powerful computer for modeling. And then for conclusion, in this study, the result can help in more effectively in landscape planning. By using 2D map, it can help in qualitative analysis. And then in 3D analysis can assist in effective planning. It is because the map show in visualization, and it will give more understanding about the landscape to the stakeholder, and also can improve the communication visualization. And then lastly, I will say thank you for hearing my presentation. Thank you.